Welcome to this video on pollutants produced when burning fossil fuels. We want to try and understand two things during this session. What happens to hydrocarbon molecules specifically during combustion, and we want to also discuss a couple of other products formed when fossil fuels burn. So first thing to understand is that fossil fuels are going to be burning in air, and air is a mixture of gases. It's mostly, as you can see, nitrogen. Around about 78% of dry air is nitrogen, and the remainder is oxygen, O2. And that's about 21%. 1% of other gases, largely unreactive. These are the main two players in terms of what the hydrocarbon is going to react with when it's combusting. So if we mix in some hydrocarbons with air, I'm using methane here as my hydrocarbon. This would work for any other. It's just that the numbers of molecules involved increase with larger hydrocarbons. So I'm using methane, and you can see that that's diffused in. Now it would be a much more even mixing, but you'll see why I've put the molecules where they are when you do that. So it's probably a good idea, if you want to follow what's going on here, to get some sort of sketch of this diagram down whilst you're watching this. So what actually happens when you apply a spark, maybe a match, or a spark from some kind of electrical piezoelectric igniter, what is going to happen? Well, the answer is a lot. So the first is combustion of hydrocarbons. Combustion of hydrocarbons. And there are actually three different ways in which that can happen. The first type is going to be, just rub that out there, just to give a bit of space. The first here is this reaction here, where methane combines with two oxygen molecules. And when it does that, the carbon and the hydrogen are oxidized. The carbon in the methane is going to form CO2, and the hydrogen in the methane is going to form H2O. And we need two H2O molecules that are formed here. So the hydrogens go there. So this reaction here is known as complete combustion. Both the hydrogen and the oxygen and the carbon have been oxidized as much as they possibly can. And notice here I need one methane molecule to two oxygens to get this done. Now, if I have slightly less oxygen around, so a ratio of 2 methane to 3 oxygen, I can actually get another reaction taking place. And this is known as incomplete combustion. And it produces carbon monoxide this time, and water. So again, the hydrogen in the fuel is becoming water, and this time I'm going to need 4 of them to make it work, and I'll have 2 COs there because I've got carbon here and carbon there. So I've got this reaction happening here, and that's going to produce carbon monoxide instead of carbon dioxide. Now, if I have even less oxygen, so this situation here, I've got 1 molecule of methane to 1 molecule of oxygen, and there could be areas of the flame where that is the case. If there's a very limited supply of oxygen, I'm going to have these guys reacting. And now, if I'm going to make H2O, so you always oxidize the hydrogen to water, all that hydrogen is going to become H2O. I'm going to make 2 molecules of H2O, and now I've run out of oxygen. I've only got 2 oxygen atoms here. I've already used 2 there, so what must be formed is just a carbon atom. So the carbon from the methane now just becomes carbon, and this would typically be known as soot. So that's the possibilities. Let's summarize those reactions here. Complete combustion, producing carbon dioxide. Incomplete combustion, you've got 2 options there. You can either produce carbon monoxide, or you've got a reaction which just produces carbon, or sometimes known as soot. And I want you to notice here, I've changed these reactions so that it's 1 molecule of methane every single time. There's always a balancing number of 1 in the equation for each of these. And I want you to notice that when I have one methane of each, you're taking progressively less oxygen to react with when you have the less oxygen available to react, the less complete the combustion. So if we were going to say here, we've got higher oxygen concentration leading to a higher degree of combustion. And so really incomplete combustion, it will be occurring in the combustion of any hydrocarbon, but it's particularly the case when you've got very limited oxygen supplies in this case. Now, there are actually other reactions that can take place. So those are the reactions that hydrocarbons can undergo. But often in hydrocarbons you have some kind of impurities of sulfur that are present, and particularly in coal, but also happens in oil. And this can actually react with the oxygen, and that's going to be an oxidation reaction that's going to produce some sulfur dioxide, SO2. So that's another reaction that can take place if you have hydrocarbon samples burning in air. Now, why is that problematic? Well, sulfur dioxide is a non-metal oxide, and non-metal oxides, this is a non-metal oxide, and that implies that it's actually acidic. And so what can happen is this can react with water to make an acid, and that actually falls as acid rain. And the effect of acid rain is shown in this picture. So what we've got here is a building that's probably made of something like calcium carbonate, limestone, and the calcium carbonates react with acids in the acid rain, and eventually it will corrode the building. And so this once sharp gargoyle is now looking quite smooth-faced. That's not it. The final other reaction that can take place here is that you can actually get oxidation of the nitrogen that's in the air. So this normally doesn't happen. Nitrogen is typically very, very unreactive. But if we have very, very high temperatures, then you can start to get the actual nitrogen in the air reacting with the oxygen. So these guys can react together to make 2 molecules of nitrogen monoxide. Let's make that a bit more clear. NO. And that can actually react with further O2 that might be around, and those guys can react further to actually make 2 molecules of NO2, nitrogen dioxide. And collectively, nitrogen monoxide and nitrogen dioxide are known as NOx, or NOx. That's where you get the idea of noxious fumes from. Now these guys are not great either. They also, because they're non-metal oxides, they're going to form acid rain. And also they can cause smog as well. So there's various issues associated with NOx's. And there's great controversy. A lot of these come out of vehicle exhausts. There's great controversy over whether diesels or petrol engines produce more NOx's, but they've become a real target for pollution reduction in recent years. So a summary of what we've seen. We can have complete combustion of hydrocarbons. That's the best case scenario, but even that produces carbon dioxide, which is a greenhouse gas. Linked with global warming. So even in the best case scenario, we're producing plenty of carbon dioxide, and really the only way to stop that is to stop burning hydrocarbons as fuels, using something like hydrogen, or perhaps generating electricity to run cars using renewable sources is the only way to really avoid this issue of carbon dioxide emissions. We've also seen, as well as complete combustion, you can have incomplete combustion. That produces carbon monoxide, which is definitely no better than carbon dioxide. This is a very, very toxic, odorless gas. Completely colourless. So it's known as the silent killer. And in situations where you've not got enough oxygen to burn, you can have carbon monoxide poisoning of people who can die in their sleep quite happily, because there's no odour, there's no colour, but it's highly toxic. Reduces the capacity of hemoglobin to bind to oxygen and essentially means that you'll die of oxygen starvation. So carbon monoxide produced by incomplete combustion, not something you want to have around. And then finally, even if you've got even smaller amounts of oxygen, you get incomplete combustion, producing these carbon, producing pure carbon known as soot, and this is actually produced in particulate size. Matter, and that is a cause of global dimming, where you don't get enough sunlight arriving at the surface of the earth, so everything looks dull. It's also a cause of blackening of buildings. And both that, sulfur dioxide, and the nitrogen oxides all cause respiratory problems in people where they're in high concentrations. Now, before we finish, just one final thing, is that the other thing that you might get is actually non-combustion, so unburnt fuel here, where we've actually basically had, there has been no reaction. And the issue with that is two issues. First, it's a waste of fuel, and that essentially is a waste of a finite resource. So you want to try and avoid that by having very efficient engines that burn high percentages of the fuel you put in, and they also are actually greenhouse gases. So we want to try and make sure all of our fuel is fully burnt inside the vehicles. So that's a summary of all the combustion products, both produced by the hydrocarbons themselves and also produced by either impurities in the fuel or, when they get really, really hot, the oxidation of the nitrogen in the air.